Okay, on this one we have to construct the histogram ourselves. Now, since this particular homework is setting it up where we have multiple choice, I'm going to talk about what I would do and then slightly alter that to match up what they've done. We're given data on the number of customers waiting for a table at 6 p.m. for 40 consecutive Saturdays. And that data is, since we can, one, count, and two, there is a smallest distance between two scores. At worst, the smallest distance would be 1, but it might be even further apart between two different scores. I'm going to put that data in order so that after we answer the first part, we can put these into a table and then construct the histogram. We need a frequency table before we can do the histogram. I'm using technology to help me with putting it in order. It doesn't have to be done, but once you get enough things, enough scores, then it becomes a much wiser idea. It's not that we don't know how to sort things from least to greatest, but when you have a lot of scores, using technology is helpful. But you want to make sure that you put in those scores correctly. Now I'm double checking that I've entered things correctly. And now I'm going to show how to sort them from least to greatest. Nope, first I'm answering the question about these scores being about a discrete variable. Again, I define discrete variables as ones where two different scores have a smallest distance between them. That is equivalent to the definition used in this book, that their finite or countable number of values. So here, filling in the frequency table, that's where I want to put things in order. So one way to get to that is press second and stats, go to the ops submenu, and the very first option, sort A, is short for sort ascending. You have to tell it which list. I put the data in list 1, so I press second and 1 to get L1 to show up for list 1, and then close the parentheses. Pressing enter, you're not going to see the results there. There's 2 options you have to do. You can go back to the table and it's put them in order. Now notice that we have class widths of 3. There's a few different ways we could look at that. From 1 to 4, 4 to 7, 7 to 10, and 10 to 13 on the left, looking at the lower bounds, or 3 to 6, 6 to 9, 9 to 12, and 12 to 15. Those are 3 apart. Something I just thought of a little bit later is that within each, you have potentially 3 scores. In the first one, 1, 2, and 3. In the second one, 4, 5, and 6, and so on. So there's a few different ways that we can see that the class width is 3. They've predetermined this for us. I'll talk in a bit here about why they're going with that. So by going through the sorted table, it's now going from least to greatest. I can count up how many I'm seeing within each class. There were 40 scores, so this last one, let's see here, if I can read this right, 3 plus 8 is 11, 11 plus 17 is 28, and 28 plus 10 is 38. That would leave 2. However, I'm double checking that I entered the scores correctly and that I counted things correctly. I think I left 1 out from my count of frequency in some earlier class. And indeed I did. So though technology can be helpful, I had to do that on my own. Now we've got our total of 40. Now they want relative frequencies. We go back to the frequency of each class and divide by 40. And a quick way to do that without referring too much to a calculator is dividing by 4 is easier to do, and then you can move the decimal place 1 to the left. For example, that first frequency for that first class of 1 to 3, if that had been 3 divided by 4, we would have had 0.75, but 3 divided by 40, it's moved it over to 0.075. Notice that it says in the directions to type that as integers or decimals. They'd all have to be decimals. You couldn't have anything bigger than 1. Relative frequencies should be at least 0 and at most 1. And then your total of relative frequencies should be 1. We're not supposed to round either. Notice that in the directions there at the bottom. This part is just reading off one of the relative frequencies that we just found. Oh, I'm sorry, that's not the case. 10 or more, they don't want exactly 10. They don't want just 10 to 12. They want 10 or more. So that's going to include the total of the 10 to 12 group and the 13 to 15 group, for a total of 0.275. Convert that to a percent, 27.5%. On the other hand, 12 or fewer, we could, notice that fewer part, again, they don't want exactly 12 that we're weighting. They don't want just the 10 to 12. We could add up everything from the first up to the second to last to get our relative frequency and then convert that to a percent. On the other hand, we could have said, well, that is just the complement. Complement is something we'll be talking about more later. The event described is the complement of the event that more than 12. In this case, that's only the class 13 to 15. We could subtract 1 minus 0.025 and get 0.975 again, converting that to a percent, 97.5%. Obviously, the last one is a quicker approach. Now I want to take a detour here for a bit and talk about how they came up with that class with the 3 versus what I would have done. I would come up with a slightly different histogram, but probably a lot of our interpretations later would be similar, if not the same. So this might seem like a detour from the detour, but it's not. Range, we'll talk more about measures of dispersion not too long from now. It's a measure of dispersion or spread, and there's more than one way to do that. Range is one of them. It is taking the maximum score minus the minimum score, which in this case is 10. Now the point of that is that's telling us how spread out all of the data is. And by the way, if I press 2nd and 1 in the home screen, I get that sorted list of data, double checking that our lowest score was 3 and our maximum score was 13. So again, 13 minus 3 gives us a range of 10. The point of it is you want to split up the data. It's like taking quantitative data, putting it into categories. Well, we call those categories, because this is quantitative data instead, we call them classes. So what we need to do is have our rectangles be of equal width. Just like your rectangles are of equal width in a bar graph, a histogram is the quantitative data equivalent of a bar graph. You want to have them to be equal width so that anybody of any age can just focus on the height to notice similarities or differences between two classes. The older we are, yes, we could do calculations of area of the different classes, but so that we're not misleading, it's just easiest to have one dimension to focus on, make all the widths the same. The lowest should be 5 or 6 classes, and the most should be 12, usually. That doesn't mean it always gets followed. 5 or 6 so that the scores aren't too clumped together and you can't tell much difference between rectangles, or too spread out with the 12. If we go more than 12, we're probably going to have things too spread out. Several low rectangles, not being able to tell too much difference between them. So what if I went with 5? I could divide up, that range was 10. If I go with the lowest one, 5, I could have these all go by 2s. However, I mentioned earlier to be going with 3. The class width is 3. So what might be going on? I would have started with the lowest of the scores, 3, and then used my class width of 2. My lower bound of the first class would be 3, the next lower bound would be 5, then the next lower bound would be 7, and so on. So 7, 9, 11, 13. I'd actually come up with 6 classes, although I was aiming for 5. Well, since the minimum number of classes should be 5, and at most 12, if I go with a class width of 2 and was aiming for 5 classes but end up with 6, that's still okay. However, as you just saw on the calculator there, they're starting with 1, even though that was not the minimum score. If I do 13 minus 1 and then divide that by 5, you can see that there are 5 rectangles in those. Well, 13 minus 1 is 12. 12 divided by 5 is 2.4. And that gives us, you could actually go by 2.4s if you wanted, if you weren't given this multiple choice. but most people want to go by a whole number. If you round that down, you could get too few. If you round that down, you'd be spreading it out and giving more classes potentially. If you round it up to 3, which is what they did, you could have too few. You might wind up with less than 5. Turns out that we do get exactly 5, so that's okay. So now what I'm looking at is where's the peak in each of those, and it appears the peak is above the 7 to 9 class for each of them, so that doesn't help us narrow things down. So I start looking at the heights of the others and the specific numbers that we're seeing on the vertical axis. If I remember right, this is the one that I wind up choosing. I hope you noticed, as I announced on the previous video, that I'm doing a voiceover here because I had accidentally muted myself when recording this. I haven't done that very many, several hundred videos, and I've done it 4 or 5 times. The next thing they're going to ask us for is a histogram based on the relative frequencies. And you could do comparisons of heights in general to narrow some things out, then start looking at the specific numbers in our relative frequency table. However, the shape should be very much the same as what we chose in C there for the histogram based on our frequency table. So now all 4 choices have the labeling with relative frequencies, things between 0 and 1. I'm double checking with some of the numbers that we're seeing here in our relative frequency table. I think I was deciding between choices A and D, and even though the far right rectangle was lower than the far left one, it was higher than it should be. I think I went with choice D, and whatever one I went with, I was correct. So I'm zooming the page out a little bit to try to compare the shape that I saw in C. I chose D and it was correct. Now this last part, they're asking us about symmetric versus skewed and some reasons. They weren't happy with my answers, so I'm going to trim some of this out. I will mention that very shortly we'll have a numerical way of testing whether something is symmetric or skewed. And I think I was letting that affect me. That hadn't been covered yet. Besides, the difference between two things was kind of small, and it's something that they hadn't covered yet, so I wound up getting this part wrong. It turns out that they are saying that this is symmetric, or at least roughly symmetric, I would qualify it with, because although we do not have an exact mirror image, when we put a vertical line segment through that middle bar, which is where our peak is, then we have something like a total of 11 when we go back to the frequency table on either side. Whatever it was, the 2 bars on the left of the peak and the 2 bars on the right of the peak, the total of those two wound up being the same.